Well, let me throw in the buzzword that I have to throw in today: deep learning.
Okay.
Right. So where do you think are we standing today with kind of the implementations and the phenomenal progress we did in the last couple 3 years to your brain research and your models and your understanding, and will we get there? Will we not get there? What's the major difference? What do you think needs to happen?
So I think right now, today, a lot of the deep learning networks, they're still essentially limited by computational hardware. So the brain actually has thousands of layers, right? I mean, as you see, like each one, and there's also feedback, right? When you look at deep learning network, right, they typically it's a feed forward and feedback, right? So there's essentially layers and then layers and then layers, and then so there's a feed forward path, right? So each one of the neurons here essentially connect to the neurons below. So there's a feed forward path, and then there's also a feedback path, right? So there's
it's layers. It's not
like fully a graph, right? So and typically, I think right now the big kind of network today, the deep networks, probably on the order of, I would say, tens of layers, right? I mean, on the order of like anywhere from 10 to 50 to maybe.
Who knows what Google is cooking on, right?
Yeah, I don't know what they do, but yeah, they maybe have something bigger, but they're not telling us.
Right.
So they're on the order of like tens, right, of like layers, right, number of layers, and that's like nothing to
of course,
brain. Compared to the brain.
Yeah.
Right?
So what needs to happen in hardware? I mean, are GPUs getting us there? Yeah,
GPU is getting us close because it allows this massive parallel computation that's really, really fast, right? And I think that's suitable for a certain type of problem. Unfortunately, the brain, I think, is actually a little more complicated than that.
Of course.
Right? So if you look at, let's think about an example, like if you look at the eigenvalue problem like the Google trying to solve, right? The adjacency matrix are basically, if you look at a matrix of adjacent nodes, right? There's actually a lot of structure in there that you can, if there's actually some structure in there, you can actually leverage computation hardware to exploit those structure, right? So the brain structure, so GPU basically is saying that, like, if you have like kind of nodes of like kind of this big matrix, right? Each kind of cell in the matrix is fairly independent of the other one. Then those are the good problem for GPUs, right? Where you don't have, maybe locally there's some structure, right? These things are non-zero, but the rest of it. So basically they're kind of somewhat diagonal along. Most of the interesting stuff kind of happens along the diagonal. Yeah. So you don't have a lot of long range type of interaction. Then those are a type of problem that's very good for GPU. Yeah. Right? But I think a lot of problem, like even the PageRank, algorithm, you do have a lot of long range activity. Right.
And I mean if you look at the CUDA API, right, it's super simplified. You only have one-dimensional arrays, and there's a lot of opportunity to improve.
Exactly, but it's fascinating though. I think that the fact that deep learning is able to kind of get us to recognize this is a beer, this is a glass, right, and that's actually pretty cool.
And it's accelerating, right? Let me.